Hello, welcome to the next edition of AWS User Group Punjab Meetup. Today we have two very special guests with us, Vishal and Kaye. Both are AWS Community Builders. Vishal would be talking about generative AI, um, how generative AI can help simplify AI app development. Kay, she would talk about applying CD using Terraform as infrastructure as code. Hi, Vishal.
Hello.
And so
So when yeah,
Vishal will be talking first. Then it would be Kay. Um, Over to you, Vishal.
thanks Amandeep. Thanks for this opportunity, and I'm glad to speak at AWS User Group Punjab. Hello, welcome to this great presentation on generative AI, and it's a kind of builder or developer's guide to generative AI. So don't panic, your brain is not going to explode. But let's talk about initially what is the generative AI, and we are probably familiar with all of this since last couple of months, or we can say about year with the Chat GPT and rest of the things that we are seeing in the market. So generative AI, we can see. So when we talk about generative AI, it comes with the multiple things. Generative AI is basically what we see or what we evolve from the existing things. So from the definition, generative AI is a field that is subset of traditional ML powered ultra large language models that includes LLMs or FMs. LLMs are multimodal languages that includes text, images, video, audio, which are enabling the new capabilities such as code generation, creating the images based on the natural language prompts, and transforming the existing ML-based capabilities such as search and chatbots that we see on similar to what we see in the Chat GPT. These are the uh, latest powered models that are known as FMs because they are incredibly powerful, and they are general purpose models, but that can also be used to extend and customize the specific use cases without having to build models from scratch, so each time for your requirements. So some examples of FM models include GPT-3 that we saw, then GPT 3.5, which was created for language based tasks, or this, if you know about the if you have heard about stable diffusion, which can generate the images from the text prompt. So if on your screen you can see the images, all these images are created using the AI models, generative AI models. This is the stable diffusion v2. You have P15 model that was created using Amazon SageMaker, that has created these fabulous images using various prompts that were provided to the those models. So let's see what is exactly generative AI and how it is implemented with other AI apps. So, as per the definition, generative AI is a branch of AI that focuses on creating the data based on the existing data that we are providing to that particular model. So, it is a subset of machine learning, and the goal of generative AI is to create a new data that is similar to the data that we have provided to train that particular model. So, if we see when we are training some model in generative AI or any kind of machine learning technology, we provide some historical data to that particular model. That might be, for example, we are considering a restaurant application that is using generative AI or AI technologies. We provide the past reservation data for that particular hotel, and then that particular hotel's data will be processed in the model trained, that model will be trained to accept the inputs for particular times, and that will calculate the wait time for that particular reservations for the hotel. So this is one example. There are multiple use cases in the market, and there are many startups evolving that are using AI technologies as well as generative AI in order to evaluate their use cases and create their own applications based upon the generative AI. Let's move to the next slide. So let's quickly go through this agenda. First of all, I'm going to go into the roadmap to generative AI and few steps that we have taken along with the path to get where are we now, and things that I think are useful to understand. To put the context around the generative AI, We'll talk about the language models. We'll talk about the text and text to image models, how we can create the image from the text. Then we'll talk about the emerging areas of prompt engineering, how prompt engineering works, what are the things that we can implement in prompt engineering for your applications. Then uh, and why it is important to us, the prompt engineering, why it is important to us. And then we are going to make some predictions from where to from where here. So maybe that is a fool's game, because generative AI is evolving much at a much higher pace than we are expecting. But I'll just give it a try on my own predictions. So let's start with the road to the generative AI. It starts with the word embeddings. So if you consider about the word embeddings, example of these, if you see the word embeddings, we are combining the multiple words. I'll just give an example of dog or a cat being close to each other. If you see the words dog or cat, those are close to each other. So if you see, they are relating to each other. So we can embed those two words together. If you see traffic and car, we can embed those two words together. So first of all, then the road to generative, how did we get where we are right now? So this is the answer from where we started. So we started with word embeddings, where we created the 2D vectors of the similar words, or the relative words that we have in our database, or that we have in our data sets. So if you see, it created the 2D vectors, or it created the separate vectors of the relative words, as you can see on screen, dog and cat, or car or bus. So these are the two different vectors that created. If I send some more data to the models, it will create more similar vectors, similar to the according to the data that we are processing. So if you see these vectors, the drive is something different than what data we are passing for another two vectors, that is dog or cat or car, bus. That those are categories of vehicles or commute, and another one are the living things that we can see, person, walk. So it created two different vectors. When it came to the another term, that is t, it was a totally different domain than what we provided earlier. So it could not fit in any kind of 2D vectors. So it was added to the third vector, and then drive was the model thought it was something different, so it was put into the different vector. So this is how the word embeddings are evolved, and it started all with the word embeddings. So these are just the statistical relationship between the words, and the number these are the numbers that we associate with the words that map where they live in these particular areas, or in these two vectors. So when we move next from the word embeddings, or we add more words to the embedding space, we can see how it starts to work. So first of all, then the word to the generative AI, how it started. As we see, it is about the predictions. It lies between the data in the past that it has in its own data set. So I mean, in the decades ago, we started to look at the language models, at the language model, how they are looking at the relationships in the statistical way between different words that we have in the documents. So we write the books that we write, uh, in the books we write words of the Shakespeare, Wikipedia, or whatever it happens to be. And so the first part of the path is when we call word embeddings. So the word embeddings are the statistical relationships between those words. So these are, as we said, if you see two words that are close together, it will embed those two words, similar to what we saw in the bus or cars. So after that, word embeddings, it came to the language models. We'll see in the in depth what are the language models, and how language models help us uh, to evolve in this particular evolution of generative AI. So we made the language models with a family of algos called word to vector. So whatever words we are passing to the models, they were converted into the vector similar to the according to the similarities between those vectors. And then last one is the NLP, or natural language processing, that includes how the computers are processing your language, the human language, into the computer understandable language that can be processed in order to create particular output that is expected by the humans. That includes the text summarization. If you see, there are many of the tools in the market that provide you even if with the chat gpt, if you provide it a long paragraph, it will summarize, give the summary of that particular text. Then question answering. The question answering is similar to what chat gpt or chat bots are there in market. This is not this is recently evolved. There were many chat bots. Many of the companies in the support team were using the question answering models in order to get the answers for their support teams in the Q&A format, so that even if you have seen, there are multiple websites. There were multiple websites since many years. Those were using the small pop-ups in order to get the question from the users and provide the answers to those particular users. After that, the sentiment analysis was one of the majorly used applications of AI that was implemented using NLP, where it used to analyze the sentiments of the users that are using that particular systems or the data that is being provided to the systems. So the most famous use case of the sentiment analysis was the vote calculation or vote estimation, which party in the elections will win particular elections. So that was the sentiment analysis use case that was implemented using NLP. And then speech language understanding. If you have heard about or if you must have used the Alexa or Siri or Google Assistants, so it is the one of the best use cases of speech language understanding, where we provide some human speech to the model and it tries to interpret that, and it provides some exact or it relative answers to that particular query according to the NLP models that it has been trained with. So the next step, as we saw about the word embeddings, if you see about the simple word embeddings, there are some things. If you see, let's go with the string, and we'll try to demonstrate how we can see the word prediction with a simple word embedding. So if for the model I passed the word as a lazy, it will just try to evaluate what will be the things that can be incorporated with the word lazy, or it will try to predict what will be there with the lazy. So what we can see, a person can be lazy, right? Or an animal can be lazy. That might be anything that comes with the lazy. So next, it could predict as a lazy, that particular model. Then as it does not have the appropriate information that is required for that particular prediction for embedding those words, it will just try to predict as a person. So when we talk about the models or any kind of AI technologies, it gives you the accurate predictions when you give more accurate inputs to that particular models or that particular technology. Okay, so what it does, these particular models, when we give it the exact or relative inputs, it will try to memorize those things, or it will check the data that is in its own memory, might be it in its data sets, and it will try to predict it using RNN are recurrent neural networks. So the it will try to just predict the next words according to what it has in its memory. So RNNs can look further back, but they're not able to see very far back due to the compute capacity. So when we see about the RNNs, it will just try to predict the next word according to what data set it has for some few, we can say some few compute powers behind. So in order to predict the word that is much related to the past historical data, it will need more compute power. So it will just look for some extent, and it will then try to predict those things. Well, but it could be the of course what we can see here is that we are missing a whole bunch of context, as in we don't know what are the previous words. If you see, there are 3 question marks, so we don't know these 3 previous words as well. So potentially we could get better outcome if we knew little bit more about what the sentence was. So now we can do that by adding some more memory into the algorithm and into our method for predicting our next word, so that we can do that something called recurring neural network, that is RNN. So if you in the RNN, if you pass few more words, it will try to predict according to what we have provided to the memory, to that particular algorithm. So you imagine in this case, the network has actually produced every word in the sentence, but it's basically forgotten to beginning of the sentence, because it does not have the beginning of that particular sentence. So it from these four sentences, it like four words: fox jumps over the lazy. It tried the person. Next, it tried to come with the rabbit. So because there might be some stories in the Wikipedia or history where it was written that fox jumps over the lazy rabbit, it could, or there might be some sentence like the lazy rabbit. There is a story also about the lazy rabbit, so it could predict that it might be the lazy rabbit, because it was missing the context in the previous words that were there in the sentence. Okay, so it's all about the what is there in the memory. So before moving to these three words that were there and how it can accurately predict it, let me tell you what is the transformers. So in the 2017, the paper was introduced transformer based models. So now this is actually this goes back actually in well time, because this is in 2017, AI or ML technologies were not much evolved, and few of the engineers from Google and other companies presented this, where they they proposed that attention is all you need. The paper name was Transformers Attention is All You Need, where uh, they awesomely titled that with this particular attention is all you need. And then they proposed many of the things where this model introduced the attention, a mechanism that enables model to learn the context of preceding words or parameters. So according to the data that we are providing, this paper proposed and designed the uh, transformer model architecture, and this is the iteration again from the types of things from the recurring neural networks RNNs, and adds a bit more complexity to that particular RNNs. But the really important thing is that this is introduced with the transformer model was notion of the attention, which is why it was in the title of the paper. And the attention was the way to have the focused contents on the title, and as well as the tokens. So in other words, we can say uh, the words that came prior to the thing that we are trying to predict now, and it gave it a complex new way to be able to store the context and process the context without running out of compute capacity and the memory capacity as well. So we'll go more deeper into this, with the practical way, so the you'll get the more glimpse of the things that I'm talking about. So the attention and the transformers inside the model revolutionize the language models as a whole. So it actually started with the revolution of the language models from these papers. And when we see about the attention, it will check what are the things that are needed to be considered in this particular model, and then it will try to proceed those things. And then let's go back to the previous slide that we were looking for. So uh, so when we see about this getting the better outcome for these particular things, let's now give our model the whole context. So consider we are training this model with the data that we had. So you might have heard about this sentence: the quick brown fox jumps over the lazy, and there is one prediction that will come. So we'll talk about just a sec in a second. But basically we have to give it ability to be able to get a context of most, if not everything, but what it has came until now. And RNNs that are not really possible because of the memory implications and compute implications, because it requires huge memory and huge compute power in order to predict the things that we're talking about before this the previous predictions before we are supplying the data to the models. But the introduction of transformer models, you can do that, and transformation models of what we are using for these LLMs or large language models, it can predict the next word. So next word for this was the dog. So it could predict probably because it has already seen that sentence when it was training. So I provided this sentence as a training to that particular model, and then it could predict that. Okay. So in between, if anyone has questions, you can feel free to put it into the chat, so we can discuss that as well, or we can discuss the question and answers in the end of the sessions. Okay. Let's move to the next slide. So next word based prediction with the transformer based networks. So it gives you some like, in order to get the far more accurately predicted text, it gives rise to the LLMs, that is large language models. And so we have gone into the history now, kind of up to date, from history to up to date. So we have gone from language models to the LLMs or large language models, and that's why I would say thanks to these transformer based models, where it will try to uh, estimate or create predictions about the words that we are trying to predict, or we are trying to get from the existing data sets that we have. So it is basically the English language program that contains all the letters. The sentence that we saw. So it could give the prediction about that particular sentence. The typing tip, it is basically, if you have used earlier programs that were used similar to what Adobe PageMaker or Corel Draw, that particular application had this sentence to check the font of the system. The specialty of this particular sentence is it has all the alphabets for in the English language. It contains all the letters of that particular alphabets. So this is commonly used for the touch typing practices, and it is also used for with the numbers in order to test the keyboards or the input, any kind of input devices. So let's move to the next slide, how these machine learning languages or AI models were evolved. So transformers have revolutionized the language models and many more things, but their performance appears to be subjective, im- as improving subjective, or it is still improving as more data is being added in those particular models. And there is as we are seeing these models, there is no sign of slowing, because these models are learning continuously. So models appear to have learned the concept through the languages such as maths. But if you see about the maths, those are the early ages. In today's age, LLMs or any kind of language models are very highly trained to provide any kind of data in any format. And so we end up in the space where we have those models which are being trained on the data now. And something that is really interesting is happening here, that is sort of very current and very right now quite often with the machine learning models. If you have this interesting and nice way of being able to process the data in your algorithms, then you throw the data, you throw data there, and as more data you throw in your algorithms uh, in a more sophisticated way, it gets these particular words in more subjective terms. And then it as we saw about the vector representation of these words, it will try to rearrange and that data in the data sets, and it will try to provide more accurate uh, outputs to those things. So we can see how this particular models are evolved according to the time, as well as how according to performance. So it is showing the size where it started with the bird, and then GPT-2, GPT-3. Right now it is GPT-4 as well, or 3.5, and then Bloom is also in trending right now. So all these, we can say, these are known as foundational models that we can use in order to train our own applications, and our own application algorithms, and create own applications according to that. So these are a few examples you can see. the BERT, GPT-2. These are the foundational models that are very large or huge models that are general models that we can use in order to fine tune those models, and we can use it as we need. So we can use those models and make the modifications to them and implement in our own algorithms in order to get a particular data. But here is where we introduce the term called foundational model. So when we started with the language models, we got two large language models. Now the foundation model, what is difference between those two models? So in terms of language processing, anyways, there are basically all those are the same things. When we consider about the language processing, it's just a matter of scale and size. When we see about when we say foundational models, it is scaled at a very hard level and very huge level, and the data that is being stored in those models is very huge. So we cannot even predict the compute size and size of that data when we are looking at those particular models. So I think the bloom was in excess of 100 days if you see about the compute time, and everybody was excited about that because it was so fast, and actually it still takes a really long time in order to process that and train that particular algorithm. So they are not kind of things, or the prediction of training those models and getting the data out of those models is really unpredictable. According to uh, it is all dependent on the compute size, as well as the data set that you have with you. So size of the data, how big is the data, according to that it will train that particular models and then get the basic predictions that we can get from that. So to be ready for a foundational model, it is real dependent upon the size as well as the compute power of your systems. Okay, so let's have a quick example of one of these models in action. You might have heard about the Amazon Code Whisperer. So Amazon Code Whisperer is the most leading tool that is being used in the market in order to for the, we can say, shadow coding. And this is awesome example of LLMs that is helping with the productivity for the developers. And in my contention to you is LLM for the LLMs and generative AI as a whole, it is going to be a most efficient way for the businesses that we are running in order to get the more productivity from the developers or for any kind of professional that are working with your code. So if we consider of the code whisperer, with a quick example, if you can see on the screen, there is an example for simple Python function that is trying to create one model. And I just wrote some comments for what I need to create, and I wrote a name for the function with the parameter, and it could create entire basic function that is required. Then I can pick up that function, modify my parameters and requirements, and it will create an entire code for that particular function that we are trying to implement. So this is very useful for the applications. If you see what it could get for the model, as we saw in the earlier slides, it could see that it has imported the torch library torch. Then it could see that I have supplied the comment called create a NN for image classification. From that it could predict what I need to do. Then next I wrote a function title create model, and then the classes that I need to pass. So according to that, AI process that particular data, that what I'm trying to do right now, and then it wrote a code, lines of code for me according to what data it had earlier in its own data set, and then it provided that particular code to me. Surprisingly, it is so accurate, and it is if you are working on some generic use cases or any kind of uh, code code samples that you have seen earlier or that are being implemented earlier, it will provide most accurate code suggestions for you. And it is really transforming the industry, the coding industry as well as developer industry. If you get time, I'll show you the demo of this particular code whisperer as well. And then in the another example, you can see on the screen, there is there is a tool or service called Amazon SageMaker or AWS SageMaker. This is basically for the foundational models. So these are available in your console. In AWS console, you can go and try out anytime. You can go to the SageMaker and launch these foundation models in your own account, and then you can fine tune those models, make them work just for your kind of any kind of AI application or any kind of application development application, to get some predictions according to that. So I recently tried this to get the flight delay for particular airlines. I just provided, use some foundational model for the wait time calculation, and from that I provided the data that I could get from the internet for the flight delays for like last 5 years, and it could predict that for particular locations according to the time that it is trying to generate. So if I pass the input for XYZ airlines, calculate the delay for between 4 a.m. to 8 a.m. and for particular day, Monday, Tuesday. So it will calculate that in a simple way. It will calculate that, and it will provide that. In an example, we can see that it has written a prompt. It is text-based algorithm. So it is trying to get the blog post or get details of the blog post according to what data it is trying to pass. So it passed the blog title or overcoming writer's block, and it passed some prompt like writing a descriptive section in a blog according to the following details. So it just provided some few details and tried to uh, provide some. So actually this prompt is very limited and it needs more data, so it is difficult to get all the accurate information, but it will try to generate something from the existing data that it has in its own data set, or in its models that are trained earlier. Okay, so let's move to the applications for generative AI. We can say we are like widely using text-based generation, that is chat gpt, that is text generation in many types. That might be the Q&A, that might be the support-based application, chatbot, or any kind of text generation that we are seeing in the market. Then game design. So in game design, there are many game producers or game companies that they are using generative AI in order to decide their strategies for the games that they are developing. So if you have heard about the uh, game that was very famous, Age of Empires, so it was a strategic game. That was my favorite game, and it had some strategy to fight with the other players in your that are living with you in that particular game, and then you need to fight with them in order to get the resources, and along with that you need to be ally with the other players as well in order to fight with the other or conquer with the big players in that particular games. So all this strategy, including what are the components of the game, what will be the characters inside the game, all these are can be generated using generative AI. uh, Obviously it will use historical data from other games in order to generate those things, and that is very helpful as well as time saving for the game designers. It will, if you see about image processing, you can pass the input to that particular models in order to generate your character images as well in all the 2D as well as 3D formats. So it can create the designs, and then you can obviously fine tune those particular designs in order to create your games. So game designers have done it very beautifully using the generative AI in order to create their strategies as well as the game characters. I have seen few of the game designers testimonials that have generated the code for their game designs as well, for their games in order to implement the strategies as well. After that, the industrial design. If you see about the mechanical industry or any kind of electrical industry where the drawings are involved, even with the civil industries where there are drawings of the buildings, drawings of the cars, or there are some 2D or 3D renderings of the any kind of components. In that particular case, the generative AI is being implemented in order to generate those things automatically. So if you consider example of car that is being designed, if they pass the uh, input or prompt to the generative AI model that they have developed. They passed that modify the car boot to be to extend it for something some or some particular distance, and if you pass that to that particular model, it will modify that design and it will increase that according to the parameters, and it will also modify rest of the parameters that are required for that particular design. So that is also widely used in industry right now. Then drug design research or DDR, that is being used in the market nowadays in order to generate or create the drug formulae according to the ingredients or uh, the things that we are passing to the algorithms. So it is trying to create or design new drugs uh, that are not yet in the market, or uh, they can be helpful for human as well as other animals in order to cure many of the diseases that we have. So it can design those things as well. So that this is in research, this is not fully implemented yet, but this is one of the applications. And then next one is image generation, that is very widely used and most of the famous applications of generative AI, where we can see we provide some inputs and then we get image according to that particular that particular input that we have provided. We are going to see the examples of one of them. We saw in the first slide there were multiple images generated, so I'm going to explain you how those images were generated using the algorithms, using the exact algorithms that we implemented on the SageMaker. Yeah, so these are the few applications we saw related to the Code Whisperer. We saw then Code Whisperer is one of the text generation based application, and game design. Or I'll show you more examples of those things as well. So let's move to the text to image in next, that is next in our agenda. So when we saw about the LLMs, it was about the word embeddings, where it used to process the word in multi-vector uh, spaces, and it was trying to create the prediction according to that. Then it came to the image models or image embeddings, where it tried to get multiple images and it tried to embed those images to create a one single image. And then next it came to the combining those both models, it came to text to image model that created the images or a single image from the multiple images that we are providing, as well as the text that we are providing in order to generate those images. So let's go through the example. One of the example of this is stable diffusion model that we are going to see for the text to image models. Let's jump into the practical examples that we can see, and I'll just show you the demo of the how these models work. So in the stable diffusion, this is this is the best example of stable diffusion. You can see we can use stable diffusion out of the box, or we can fine tune that model according to our own data sets. So for this particular example, I used the puppy, Marigold the puppy, a dog, that the photos of these images. So these images of Marigold the puppy are real, and I provided that for training that particular stable diffusion algorithm. Now with the stable diffusion, it is one of the foundational models. So what I'm going to do here is I'm going to show you how foundational model works and how it will generate that particular images, how it will provide the data in order to generate those images. So it might generate the image that we have never seen before, and that might not be the factual, that might not be the possible in real world, but it will just generate those images according to what data that we are passing. So that's why I said whatever we can imagine, we can create using generative AI. Even if it's just imaginary, we can create it. So on the left side, we can see we passed the actual photos of that Marigold puppy, and I applied the stable diffusion model, and I gave a text as we are talking about the text to image. I provided a text prompt, a photo of a Marigold puppy as a street art. So if you know, street art is similar to what we call it rangoli. It creates the art on the street. So I provided that to stable diffusion model, and stable diffusion model created this particular photo. Might be this is not relative, or you cannot see that as real, but it tried to create that according to the data that we passed to the stable diffusion model. So in this particular example, what we did is we passed the 4 photos of the puppy. According to those 4 photos, it processed using stable diffusion and generated a new image of this marigold puppy. And then as the stable diffusion model was known about what is the street art, it tried to manipulate that particular text string or prompt that we provided, and it tried to create the street art according to what it is trying to, uh, according to what we supplied, and it tried to create the street art. So it looks like a pastel on the street, and it is entirely an image that is not created anywhere in the world yet. So according to how we fine tune these particular algorithms or these particular models, it will try to provide most accurate images as well. So next, I try to modify my prompt, and I try to pass a photo of marigold puppy with 8-bit art. So if you know the 8-bit art, it is kind of the old age games. If you know about the Mario or Contra, those were the 8-bit games, and it used to have some 2D or plain image based characters when we try to play with them. So we tried to create this 8-bit art from the input that we supplied according to the puppies that we have. You can see it has tried to get many of the characters from existing images that I provided, and then it tried to create the 8-bit photo of that particular system. It has created the background. So if you see, this stable diffusion training model has improved a much a lot, and it is trying to create an image as accurate as possible according to the parameters or text and images that we are providing to these diffusion models. So let's move next to the how stable diffusion model works. I'll just run you quickly through those things. We are running out of time, so I'll just run you through how diffusion model works for the generating these kind of images. So for diffusion model, I pass this particular image, and I try to get how it can create a new image. So there was no fancy prompt for this. I just tried to pass the image and asked it to create a different image from this image. So what it is trying to do is it will try to add some noise to each image to learn backwards to the original image. It will add noise, and it will check, will train the model by adding the noise, and it will try to see what is there in the previous image. Okay, so well, going from the from that point where we are having a little bit of noise, let's add more noise to that particular noise, and then we can see we can work backwards in order to get the previous image and difference between those images. So in these iterative steps, each step is itself doable. So it is trying to get the components of the previous image, and it is trying to check in the models, in the stable diffusion models, how we can generate a new image according to that. So in the next step, it is trying to remove the noise gradually, and then after training like these images, we can use, like, this is just one example. If you see about the million images that are being trained on the model, it will try to create those new images according to the data set images that it has already. Okay, so if you see about this example, we have not given any fancy prompt. So at the end, it could create a different puppy from the what original puppy that we provided as input to the diffusion model. So that was totally different. It could just try to create a background might be the different, or it tried to change the background as well, and it tried to create a different puppy from the existing puppy that we provided. So algorithm could detect that is a kind of puppy, and then the trained model could generate a new image from existing image. So let's see another example of the diffusion model. I modified my prompt or input to manipulate the puppy on the space station. So this might not be possible, or it might be the possible down the line after 5 or 10 years. The space technology is evolving at a very high speed, so that might be possible as well. So in this example, we can see this has not happened yet, but still the image is generated, and you can see this is definitely new and unique. So what it did, it from the images, the 4 images that I passed to the stable diffusion model, it tried to create an entirely new puppy, and then it tried to create an image of the space center in the background with the earth. You can see the details of that image. It created, it showed the earth in the background, it could show the space station, and puppy was fit into uh, that particular space station. Okay, So this was about the stable diffusion. Let's move to the prompt engineering. What is the prompt engineering? So in the previous example, we saw Marigold the puppy on the space station. So this is called as a prompt that we provide to any kind of models in order to get particular results. That might be the text-based, image-based, any kind of things. So if you see a simple prompt application, first of all, let's consider this. You want to generate the application that is going to write your blog post. And if you want to do that, by the way, unfortunately, you are not going to the first to do this. So many people might have created this app. So let's have a look at how it will write those blog posts. So here, uh, uh, here I can type in the title of the blog. I can type in the topic of the blog post and maybe the length, how much paragraphs I need for those particular that particular application. And then I'll need to provide a prompt for that particular blog. So prompt can be really long or that can be really short. So what prompt I provided to the that particular algorithm or that particular application, you are a journalist and all the details about uh, what blog I exactly need to generate. And then at the end of the list, 3 prompts that can be used to generate the images. So it will generate the prompts as well that for that particular application. So that can be called as recurring prompt engineering, where we can pass the prompt in order to generate the prompt for particular applications as well. So this is one of the applications. If you see in the highlights, this was the prompt used in order to generate the blog according to what title, topic, and length I provided to uh, particular application. So prompt engineering for training. So if you see, prompts are generally used majorly for fine tuning your models as well. So these are a few of the sample prompts that are used as a labels for training the data in your data sets for training the algorithms. If you remember back to the prompt of the Marigold the puppy, when fine tuning is stable diffusion, we passed various variations of the Marigold the puppy in order to get the exact images. Even if you see about the example of the text based generation, we updated our text string in order to get the most accurate things. So in this particular example, if you see the blog generation, we provided some prompts that has some unique keywords, announcements, AWS CDK, DevOps, that are used as a labels when you are trying to generate some data from the content or from the models. So prompt labels are used for this training. So in this particular example, we can see, I'll show you how it has generated it. I'm not sure if you can see the text, but from the prompt, a blog post for a AWS news blog written in an information style with the technical details and pointers for how to go get started with the particular service. So this was the prompt, and it could generate an entire blog post according to the prompt that was provided. So in background, the prompt engineering was used for training that algorithms and to identify these particular keywords or labels that we are seeing on the screen: DevOps, AWS code pipeline, best practices. And according to that, it could generate the most accurate blog post that we could see on the screen over here. So prompt engineering also is also important. With the prompt engineering, many people are making money as well, creating the most accurate prompts, because as I told you, for the AI or any kind of applications that are based on generative AI, as accurate prompt that we provide to that particular models or application, it tries to provide you most accurate results that we intend. So there are many startups that are creating the prompts and selling those prompts to the users in order to get the business specific use case data. That might be the any kind of Excel formulas, that might be the email templates for particular business use cases as well. Okay, so let's move to the last few slides of this presentation. So where to from here? So we saw where is the generative AI right now, and I would say it is evolving daily. And when I'm getting up in the morning, I can see in the Twitter or LinkedIn there is something new invention happening daily with these particular generative AI technologies. So what will happen next is models. We saw LLMs and FMs. So these foundational models and large language models will get bigger and bigger and more sophisticated with most accurate data sets that it has. Then many developers will use the foundational models and prompt engineering in order to get in order to train their own algorithms, and in order to get the intended business use cases resolved. So they will use those models and they will fine tune their own algorithms and applications in order to get the most accurate results for that particular applications. And then next one is training cost and sustainability will come into the focus, because right now in order to train those models, if there are many costs involved. There are carbon footprints, there is heat generation, because as I told you, there is a very huge compute power being used in order to generate the responses as well as training those models. If you know, in order to train the models, we need to provide huge data sets to the algorithm. So with that data sets, it needs a huge power in order to process those data. So sustainability will come into the picture, and that has already come into the picture for sure for the generative AI applications. OpenAI had a few days ago published how much carbon footprints are required in order to generate a single thread that we are using in order to generate some responses. And then next, yeah, interface cost and sustainability, as I spoke about. And then when we think about the cost, it comes with the algorithm optimization. As more you optimize your algorithm, it requires more compute power, and with the dedicated hardwares for the LLMs, it will definitely affect the training cost as well as sustainability. Okay. So for the generative AI on the AWS, we have Amazon Bedrock. That is very fabulous service provided by AWS that has the majority of the foundational models that you can use. You can just search for your use case and get the foundational model according to your use case, and you can use that. Then Amazon has provided few EC2 instance types, EC2 TRN1 and EC2 INF2. Those can be used in order to train your models. And then Code Whisperer is the uh, tool that we can use in order to predict the code that is required for particular developers for any kind of languages. So these tools are evolving day to day. There are new technologies being added to the tools, and these are very useful tools we can use for generative AI. We saw Amazon Bedrock. So Bedrock has these particular foundational models. So these are the from leading startups, AI startups that are there in the world, as well as from the Amazon. So Jurassic 2, Cloudy, you might have heard about this stability.ai, that is based on the stable diffusion that we discussed. Then Amazon Titan, that is used for the text-based information summary. So these are few of the models that are provided by Amazon Bedrock. It's surely giving a try to check what are the models, and you can just try to explore these models by logging into the console and Amazon Bedrock. Then we talked about the SageMaker. These are few of the screens from the SageMaker where we can see multiple algorithms. And then there are three things that in the SageMaker. There is Studio Lab, that is free of cost. You can explore free of cost. That doesn't cost you for using this SageMaker Studio Lab, where we can explore the SageMaker's capabilities using this is, as I told you, this is completely free and you can use for learning and experimenting with the ML workloads. So consider you are trying with some particular applications, you can go to the Studio Lab, and on the front end page you can see there are multiple algorithms. You can pick up any one of the algorithms and try providing some data sets to it, and try with some input prompts as well. Okay. Then after the SageMaker, we have SageMaker Jumpstart, that has also multiple advanced algorithm that you can use in order to get particular data and data sets according to the uh, inputs that you are providing according to your particular application. So there are ready to use cases in this particular Jumpstart that you can use. And see, you can say model zoo. It is called model zoo, which is a large collection of open source pre-trained models that includes many of the foundational models. and it can actually take the, you can directly deploy them into your account and fine tune them and use that with your own use cases. And last one is the foundational models that we saw earlier. We can pick up any of the foundational models and fine tune them in your own applications in order to get the intended data for any of the use cases. So there are many foundational models according to your use case. You can pick it up. There are many basic models such as depth search. Many of the data structure algorithms are there as well. So you can go to the SageMaker console and give it a try. Okay. I think yeah, we are good with today. I'll just after the all this, I would say you can follow me on LinkedIn. I'll just give a quick introduction of myself after this session. I'm working with Forcepoint Software as a senior DevOps engineer. I'm AWS User Group Pune leader. I'm associated with many of the user groups in India, and I usually talk with various conferences, community days, and meetups. And I'm also AWS Community Builder. Recently, there were many new community builders introduced, so I would welcome them to the team. And yeah, I would say thanks to the AWS User Group Punjab and Amandeep sir for giving me this great opportunity. Thank you. If you have any questions, we can go with that. Thanks.
Awesome. Thank you, Vishal. Um, so one question we have is, are the foundation models free to use?
Yes, Rani. So that's a good question. That depends upon your use case. There are many free foundational models available over there. You can go to the SageMaker console and try that. If those models are created by some startups, as we saw in the previous screen, they might charge you for the API calls that you are giving to uh, your particular that particular models in order to generate the data, because they have invested in developing or training those models, so they might charge. But there are many of the free foundational models as well in Amazon SageMaker. You can give it a try. So if there are some basic use cases, you can try with that as well.
Cool. We have another one.
Mhm.
Request is to repeat how generative AI is used in the design research.
Okay, I'll just go to the slide. Yeah. So when we see about the drug design research, for each of the chemical compounds, it is basically used for the chemical compounds. When we see about the scientific research and gene research, for example, and the chemical compound research is one of these places where it can take the kinds of training of the data, which is essentially the gene sequencing or molecular structuring uh, of the data that you are passing. And you can apply the same kind of embeddings that we did to the language models, as we saw in the previous examples, and use these structures and ask generative AI to play around with it, and it will come with new structures, with the new properties and potential that we have never thought of before. So when we consider of drug design research or DDR, it comes with multiple ways in order to generate a new drug or new chemical compound according to what data it has in historical trained models, and it will generate a new compound that we have not seen before. So that might be helpful with the creating the compounds or creating the materials that are very useful for any kind of applications, or that might be useful for uh, healthcare industries in order to get a particular drugs or medicines for any kind of diseases or any kind of preventive measures as well. For the, as we saw for the COVID, it would be useful in order to generate the drugs according to the composition that we are passing through the models. So I'll share you the quick link of how the medical drug research is using AI.
Awesome. Thanks, Vishal. You can share that in chat.
Okay.
And we really appreciate your time. And
Mhm.
thank you so much for um, sharing this talk with the user group. And hope to see you again in the near future.
Thanks, Sumandi.
Vishal would still be available in chat for some time. In
Yes.
case you still have any questions, please feel free to ask in the chat.
Yes.
Thank you. Next we have Kay.
Good afternoon.
Hi, Kay. Um, Let me quickly give a small introduction about Kay. She's a DevOps engineer of the API and integration management team at a company called Asurion. From before that, she was a specialist in IAM, the Identity and Access Management of AWS. Um, and prior to that, she was a full stack engineer at utilizing Microsoft .NET technologies. Also had experience in ETL. So apart from that, she's also 6 times AWS certified. So that's a big thing. She's a fellow community builder, and we at AWS User Group Punjab thank you, Kay, for taking time out to uh, present to give a presentation.
Yep.
Over to you, Kay.
Yep. Thank you, Aman. So I'll dive right in. Yeah. Good afternoon, everyone, and I'm Kay. So today I'll be talking about the topic of applying CB, deploying a demo app on EC2 with Terraform IaC or infrastructure as code. So thank you, Aman, again for giving me the opportunity today to talk about this topic here in the AWS User Group Punjab event. I am also a user group leader, and I really appreciate other leaders who contribute back to the community by organizing these events to help the community learn and grow together in tech. So hopefully you learned something from me today. Yeah. So just a quick run through about the user groups that I'm associated with. So it's the User Group Philippines and also the AWS UG Builders Plus, which is basically a subgroup of the larger User Group Philippines. And also a community builder, which is where I met Aman also. Aside from the previous time that we were in another conference of AWS. So I'm also encouraging everyone watching to be actively involved in growing the community because one of the benefits is the support from AWS, such as the free certification vouchers, which is also why I got certified a lot because I got a lot of freebies from AWS. Okay, so let's go straight into the topic. So, an overview of what we'll be discussing. We'll be going through the definition of infrastructure as code, and we'll also discuss about the architecture of an infrastructure, sample infrastructure that we are going to build using IaC. And I'll quickly also discuss about image builder as a service, which can help us build an AMI, which will then be used in our Terraform code to build out the infrastructure. And then I'll show you briefly the output in the AWS Management Console. So this is HashiCorp's definition of infrastructure as code. In the DevOps world, one IaC tool is Terraform, which is what I'll show you today. So hopefully once I walk you through it, you'll get a gist of what it is and what are its benefits. But for me, at least, the benefits of having infrastructure as a code is you have consistent infrastructure across environments, and you can have versioning of your changes to the infrastructure, and your code can also be reusable, and you can also share it across different infrastructure modules. So here is the infrastructure. We'll have image builder build out an AMI for us, and using that AMI will be deploying this architecture where you'll have a load balancer routing traffic to highly available EC2. So there should be at least two. Just in case that the other one goes down, you still have the app live. And we'll have an auto scaling group that does that for us. And this whole infrastructure will be deployed in one VPC, and we'll be using the Terraform code for it. So on the first step, we'll be building the AMI with Image Builder. Image Builder is an image pipeline, so you can continuously build an AMI at no additional cost except for the underlying infrastructure that you're going to be using. So it simplifies building, testing, and deployment of VM and container images, and it can be used on AWS or also on-prem. It has the capability to allow customizations on your image and export the image to make it accessible across regions and even AWS accounts. So the steps on how an AMI is built with Image Builder is you start with a source image, and then you have components that you can allow customizations. For example, you want to install YAM updates, you want to apply security patches, and also install the application so that every time that you bring up your EC2, the application is already installed there because it's packaged along in the image. And another good feature of Image Builder is you can have testing components. So you can test your image even before you complete the AMI build. So you can ensure that it works as expected. And lastly, you can distribute this golden image across regions or other AWS accounts. So yeah, let's build the image pipeline. So the steps are basically divided into three. You create a recipe. Recipe is like in cooking, it's like the ingredients and the sequence of cooking. Then you have the infrastructure configuration. So think of it as where you will be cooking that recipe. And then lastly, the distribution. This is like, think of it like the stores where you'll be selling the food that you have created. So to get started with AMI Builder, you navigate through the Image Builder service on AWS. And on the left pane, you'll see there an image pipeline. And there's a button, Create Image Pipeline, to start building the pipeline. Now, first step is to specify the pipeline details. Here, you can put the pipeline name, description. Like, for example, you're building a sample Apache program. So you can specify it in the description. And you can also specify a build schedule to instruct Image Builder to build a new version of the AMI on a regular or a cron-based schedule. So for example, you want to build the AMI monthly in case there are any updates to the image. And then you can also trigger the pipeline manually in case there's some dependency updates on the components that you want to specify. Yeah, so next is you choose your recipe. So it can either be an existing recipe or you can create a new recipe. So here I'm selecting an image type of AMI or something that can be deployed on EC2. And yeah, just showing you that there's also an option that you can build also a Docker image using the image builder. So for the build components, so there are several options for you to select from. It can either be an Amazon managed component. These are pre-built components that you can easily add to the pipeline, or you can also do some customizations. So yeah, those are some options for you that you can use. So for this particular pipeline that we're building, let's do something custom. So this is just a sample code of a build component. So it's in YAML format. And you basically say, for example, in the first part, you say download install script. So I am downloading from the source, which is an S3 bucket called Bits Collective. And I have a shell script called install Apache. And then the destination will be on the EC2. I'll have a var temp folder where I'll have the same name of the install Apache script. And that will be what this first step does. And then on the second part, it's called run script. I'm basically saying that this is an action of execute bash. So it's just some sequence of bash commands. And for the first command, you can see here chmod 755, and then there's a variable. So this one is referring to the first part. So build.download install script .inputs 0 .destination. So this means that I'm changing the permissions of the file, the destination file, which is var temp install Apache, to 755. And then on the second part, bash, of using the same variable, I'm just saying that I want to run this script. So the first two steps is basically download the install Apache script and also run it. So this is the the install Apache script contains. It's just a simple yum install command of Apache, which is httpd, and also starting and enabling it on the machine. Now, the second part of the custom build components, I also want to have a sample application. So basically, I'm also downloading an index.html file from my S3 bucket and putting it on the var www index.html folder, which Apache will read from. And then after that, I'll be also cleaning up the install files. So basically just removing the install script that I downloaded earlier. So that's what this action does. And the content of the index.html file is just a simple hello message sample application. So that's it. Now, this will be, if I create that build component, I can add it to the pipeline. So it's under the filter owned by me because it's custom. Okay, now the next part of the pipeline, you can also optionally create an infrastructure configuration. So for example, you want on the EC2, you want to define it as something of R5 large, or different instance types, or any configuration to the infrastructure, you can put it here in the pipeline as well. And lastly, another optional setting is the distribution settings, where you can also define here what regions or accounts can access the created image. So actually, when you run the pipeline, you can specify that I want it across two of my accounts, two of my AWS accounts, or you can also put it accessible across US East 1 and US East 2. So that's this step. Now, after you built out the pipeline, you can now run it. So you'll see something like this, where you can filter for the pipeline that you created, and basically under actions, just run the pipeline. And once you run the pipeline, you can see the workflow of each step that it's running. So there are 7 steps here. It's launching a build instance, applying the build components, etc., until it then terminates the build instance once the AMI has been created. So you can see here, it's basically just running. And the output will be the AMI. So you'll see here that it has an image ID, AMI 07, blah, blah, blah. And this is now accessible for me to use in my Terraform code. And before I do that, I want to quickly test if the image is working. So under EC2, I would navigate to the Amazon Machine Images, where I can view the created AMI here. And basically, there should be a button there. It's saying launch instance from AMI. And that instance, you'll get the public IP, and you can see that the application is successfully running on this instance. So I can now tear it down because I'm sure that it works as expected. So that's it. That's the first part of the infrastructure. Basically, we just created an image pipeline which created the AMI for us. Now, the second part here is that AMI that we created, we want to basically use it in our Terraform code to build out this architecture that we talked about earlier. Now, let's talk about Terraform. So Terraform is a tool for creating infrastructure as code. And infrastructure as code as a concept, it helps manage infrastructure with configuration files instead of using the AWS dashboard. So instead of building your infrastructure manually, using the management console, you can use any infrastructure as code. It can be CloudFormation. Terraform is just one, and then you can also have CDK. So there are many options for you to use. Terraform is my favorite because it's very simple. It's very easy to learn. The syntax is very simple, and it's also cloud agnostic. So you can use it across different cloud providers as well, not just AWS. So the prerequisites for you to work with Terraform, of course, you have to have Terraform CLI is installed, and then you also need AWS CLI installed for you to be able to interact with AWS. And of course, you need the AWS accounts and credentials that has access to create your AWS resources. So I'll share with you a link later on about how you can do this, but I won't be running through each one because that would take some time. But let's assume that these are the prerequisites that you have already gone through on your machine. Now, to talk about the different Terraform commands, so basically there's four most important commands that you need to always remember. So first is initialize. This will install the plugins that Terraform needs to manage your infrastructure code. The next is plan. This previews the changes that Terraform will make to match your configuration. Then, if you want to run your Terraform code, you run apply, which basically makes your plan changes and applies it to AWS. And then lastly, there's destroy, which is the safest way to destroy all your infrastructure defined in code. So using Terraform destroy ensures that you remove everything that was created also by your Terraform code. So it's a very clean cleanup that you're doing. So let's dive into creating your Terraform code. First, you'll have to create a main.tf file with the following contents. So as you can see here, there's a first part saying that your provider is AWS. So you're interacting with AWS. And then I also have here Terraform declaring backend. My backend is S3. I'm using the bits collective bucket in US East 1 region, and I'm creating a state file called AWS EC2.tf state. So it will be stored in the S3 bucket bits collective. Now, the second part is you can also create a vars.tf file, which basically is just a collection of variables that you have. So it's just putting together all the variables under one file so that you can easily reference them across your code. So here I'm just using a simple variable called AWS region. So for example, I want to reuse my code on a different region. I can just simply change the value here and it will be a reference across my code. So this is the right way to do it, having a vars.tf file. Okay, so let's assume that those are just the files that you created, and then let's go through the first command, which is Terraform initialize. So if you see here, when you run Terraform init, it basically initializes the backend and creates these two files. So you'll see that Terraform folder created under your directory, and there should also be a terraform.tf state file created. So this is the provider's folder with the Terraform executable, and it's also downloaded in the folder. Okay, now let's build a sample code for Terraform. Let's add a resource. So as you can see here in the syntax, it's resource. And then the first part you'll see is AWS underscore instance. So that is the instance type. So what type of resource am I creating? Basically, I'm defining here that I want to create an EC2 instance. And then the third part, which is app server, this is the resource name. So this can be anything. I'm just saying that I'm creating an instance with an instance name app server. So this is like an ID of this resource in the Terraform code. So it should be unique across your whole code because you can create two AWS instance resources in your code with the same name. So basically, it's an identifier of the resource that you're creating. Basic parameters of an AWS instance, of course, you have to have an AMI that you're referring to. So here I'm referring to the AMI that we created previously. This is the ID of that AMI. And then I'm saying that the instance type that I want to create is just a T2 micro. And then I'll add a tag that specifies its name as example app server instance. Okay, now let's do the next command, which is Terraform plan. So if I run the Terraform plan, you can see that it will create the plan for me. So you'll see what resource is being created, will be created by your Terraform code. So here you can see it's the plan is saying that there's one resource to be added, none to change, and zero to destroy. So basically, since I only put in the code for EC2 instance, so it detected that I need to be adding, the plan will be creating a new EC2 instance. So that's the one that's being specified here in the plan. Now, if I run, the next command is Terraform apply. It's basically the same. It will run through the plan again, and then at the end, it will ask me a question. Are you sure you want to perform these actions? And just type yes, and it will basically run the Terraform script for you. And you'll see something like creating until creation complete, and then apply complete. It says one is added, zero change, and zero destroyed. Now, you can now check it in the AWS dashboard. You can see here that an instance has been created with the name example app server instance, and it's in an instant state of running. Now, also part of the code that we run when we did it, since we specified the state file, the Terraform state file, to be created remotely in the S3 bucket, you'll also see that state file created in the S3 bucket here in Bits Collective. You'll see AWS EC2.tf state. So this file will keep track of any changes done to the code. And the benefit of keeping it in a remote location, because you can also store it in locally, but the benefit of putting it in a remote location such as S3 ensures that any remote server will follow a single source of truth for any updates to the infrastructure code. So for example, I'm a developer and I ran the code, and then another developer did some changes, and then he runs the code. So it ensures that we're only referring to one state file, which is in the remote location and accessible to both of us. Because if I put in the changes on my local, that the other person cannot see what happened to the state file. So it will be conflict in that case. So the best practice is always putting the state file in a remote location. Okay, and then the last command is Terraform destroy. So you'll see here, if you run the Terraform destroy command, it just basically said that there's one to destroy, and you can put in yes to confirm, and then it will now destroy the infrastructure for you. There. Now let's go through Terraform modules. So that's just the running through the Terraform commands. Now let's start to build out our whole architecture again. Now, Terraform modules, this is nothing but putting together infrastructure code into a logical group to allow reuse on other parts of the code. So here you'll see that I grouped the infrastructure code under one folder called HA application. So ultimately, I want to be able to reuse this module when deploying the same infrastructure code across multiple environments. So for example, dev, QA, staging, or prod. Under this folder, there's a vars.tf file that would have default values, but it can be overwritten whenever you're calling the module so that the values can be updated when deploying across environment. So for example, I want the EC2 instances in my dev environment to be called dev. So I can easily overwrite the name if it's stated as a variable in the vars.tf file. And then in my production, I want to name the instances as prod. So easily I can just invoke again my module and just pass the value of prod to the name so that the instances deployed in production will have that name. So that's the purpose of Terraform modules. Basically, you're just writing one code for deploying to different environments, or it can be also across accounts. Okay, now let's go through the main.tf file for our Terraform module. So here, when you're going to invoke it, basically you're saying that it's a module and application is the name of the module, and then the source identifies where the module is. So here it is in the modules folder and the name is HA application under this folder. And then the customizable variables are the 4 parameters at the bottom. So I can change the AWS region, I can change the image ID, I can overwrite the availability zones, I can also overwrite the VPC ID. So those are the things that I made as a variable. Now, on the module part, so what are the parts of the architecture that we're trying to build? Basically, there's 5 resources that I want. So first is the launch template. So this is an AWS resource that specifies the instance configuration information. So it will include the ID of the AMI, the instance type, a key pair, security groups, and other parameters used to launch the EC2 instances. So basically, I'm just defining what the values are going to be for my launch templates. I'm saying image ID will be getting its value from the variable image ID. The instance type will be T2 micro. Update default version will be true, and then my security group IDs will be this ID. So this is one resource which is part of the main.tf file. Then I also want to create a target group. The target group is basically a pointer to the different EC2 instances. So a load balancer will point to a target group, and the target group will have registered instances where the traffic will be routed to. And you can also specify here some health checks for your target group. Then another resource is the auto-scaling group. So one benefit of the cloud is having high availability. And for an EC2 infrastructure, the auto-scaling group is the one that does that. So here you can see some configuration. There's min size, max size, and desired capacity. So basically, I'm saying here that the maximum size of my EC2 instances is 2, and the desired capacity is 2. So it will ensure that I always have 2 instances at a time. So if any case that one EC2 instances shuts down for any reason, the auto scaling group will simply spin up another EC2 instance for me. Another resource is the load balancer. So a load balancer will always have a listener. So the load balancer, basically it routes traffic across the registered instances on its target group. So here I'm saying the name of my application load balancer is application LB, and it will have these security groups. It will have access to the following subnets, and it will also have an idle time out of 60. And then the listener will be here. As you can see, something I want to point out here is under default action, you'll see the target group ARN. It's AWS ALB target group.http.id. So let's go back to the target group. Basically, this reference is taking the ID, which is the output of the target group that I created previously. So you'll see it's AWS ALB target group.http.id, and that will be used by this part, the listener. So basically, this load balancer will have a listener that is also pointed to the target group that I created in the first part of my code. There. And yeah, that's it. That's the whole code. Now let's start Terraform apply. So it will say Terraform will perform the following actions, and it will detect that there's 5 resources to add, 0 to change, and 0 to destroy. And if I click yes, it will start to create my resources for me. Let's actually go through this in the dashboard instead of the PowerPoint so that I can show you. So you'll see the first part is a launch template. So it will have been created under here in my launch template. There. Now, the launch template will have the information such as my AMI ID. So it will be here. And then another resource created is the load balancer. So you'll see here the load balancer will have a listener, which is port 80, and it's forwarding traffic to application TG target group. So this is another resource that was created. And if you navigate to target groups, you'll see here that it has targets. It has 2 instances where it's routing traffic to. Now, these are the EC2 instances here. And you'll see that they are live here. And yeah, that's it. And you'll also have an auto-scaling group here that where you specify the desired capacity, minimum capacity, and maximum capacity. And this will ensure that you'll always have 2 instances at a time. And it will spin up, like I said, it will spin up an EC2 every time one of them gets destroyed for some reason. Now, if you go to the load balancer, you should have an DNS name here. And if you browse through it in the console, you'll see the application is up. And another suggestion here is, since this is only HTTP, you can see not secure in the web browser. But if you can also put in an SSL certificate to make it more secure, to basically convert it into HTTPS traffic. Yep. So that's it. Another thing I want to point out here, since if we still have minimum time, you'll notice here that in my target groups, I intentionally put this instance in the US East 1B, which is basically not accessible for my load balancer. So if you can see my load balancer here, it has only the following subnets: US East 1B and US East 1A, which is why in the target groups, it's saying this warning for me that this instance is not in an availability zone that is accessible by the load balancer. So basically, this instance is not receiving traffic. So let me do some minor change on my load balancer here. So you can see I only have two subnets. So let me add the other subnet, which is for US East 1D. But I need the ID. So let's go here and get the ID of the subnet. And let's add it here. Okay, so now you see I added some change to my Terraform code. So to apply that, I just need to run Terraform apply again. Oops, I need to run my initialize again. Okay, I'm in the wrong folder. Let me run Terraform apply, and it should be able to detect that I added a subnet on my application load balancer. So it's now running. Okay, so now you see that the plan is saying that there's 0 to add, but there's 1 to change, because the load balancer is already created, but I introduced an additional subnet here. So do you want to perform these actions? Yes. So if I click on yes, it will create that. It will basically update the load balancer for me. And now, once that is done, hopefully it completes fast. It's modifying the load balancer here. And let's quickly go back to the dashboard to see if the load balancer now has 3. So you can see the availability zone has been added because the code has completed. And let's go to target groups again. We'll see that it's now healthy. So that's it. So yeah, thank you. That will be the end of my presentation. So I can entertain if there would be any questions for the presentation.
Thanks, Kay. That was really helpful. I will probably take a few questions from chat. So there's a question that I think that's not directly related to our topic today, but it says that can Terraform be used to create AMI on M1 Mac? VirtualBox is not supported there.
Um, Using Terraform to create AMI in a local machine on M1 Mac. It's probably not the proper way to do it. I would assume that you would only create an possibly image builder will be the right tool to use when you're creating an AMI, because Terraform is mostly on building out infrastructure instead of AMIs. But it might also be possible you can just search for the documentation of Terraform. It's easily accessible in their website, but I don't think I've heard of using it as something to build out an AMI.
Okay. Then would there be any GitHub repository for the Terraform examples you
Oh,
shared, which
yep.
can be followed by others?
Yep. Basically, I have it here, but it's not yet shared. But right after the session, I'll be sharing it publicly. So it will be under my GitHub, which is under Coder K AWS Terraform EC2 app.
Awesome. And then there is a request to
Oh,
take more time again.
yeah, of course. Yeah, you can message me on LinkedIn. I think Aman also linked me in the post of this session, so you can always message me there. I can help you out if needed.
Awesome. Thanks again, Vishal and Kay, for taking out time today for AWS User Group Punjab, and hope to see you again in future. Thanks all. Bye.